What's going on, guys? Welcome back to the Better Math Tutoring, and we're going to start working with pre-calculus course. So the first thing you need to kind of review and master from the previous class, which is Algebra 1, is lines. So we have plenty of videos on our channel when it comes to lines. You can feel free to go check them out, and those cover literally everything that you need to master about lines. But let us do a quick review of what you need when it comes to linear equations and lines in your pre-calculus class. So we're going to step it up a notch a little bit and use lines to solve different word problems, different economic problems. So I want you to be very, very comfortable with solving lines, knowing how to draw a line, the difference between parallel and perpendicular lines, and moving through different formulas of a line. But let's start with basics. So just as a reminder, we denote lines as y, and obviously they do the first degree. So for example, let's do 2x plus 1, right? This number attached to x is our slope m. And if we have 2 points, we can find the slope using y2 minus y1 over x2 minus x1. So it's rise over run. So we have a point A that, let's say, has x1 value and x2 value. Y1 value. And then we have a point B, which has x2 value and y2 value. So using this, you can quickly find the slope. And this number right here, as you recollect, is your y-intercept. So this is the point where your graph of a line interacts with the y-axis and your x is equal to 0. Okay, so this is called the the slope-intercept formula. So you have the slope, you have the intercept. Additionally, we have something that's called the point-slope formula. And as the name indicates, we are going to use the point and the slope to write it out. And it goes like this. Given that we have point P, x1, comma, y1, and some slope, then we can use that information to write it out in the following way. Y minus y1 is equal to m parentheses x minus x1. And when you plug in the values of the point and the slope, all of which are going to be numerical, you will end up with the slope-intercept form again. Lastly, we have something called the standard form. It's not commonly used, but you should be comfortable with it anyways. And it goes like this. ax plus by is equal to c, where a, b, and c are just numbers. So we're going to do some more problems transitioning between all three formulas, or you can simply head to one of our videos from Algebra 1 that go in depth into moving between all of the three formulas. Okay, so we got that out of the way. Why don't we start working with finding the equation of a line? So in order to find an equation of a line, we need three things. Actually, two things. Number one is the slope. And number two is a point. Or preferably 2 points, right? We can either be provided with the slope, right? So we can have a specific m equal to a number, let's say 2, like in the previous case. Or if we have point A, let's say 2, 3, and point B, let's say 5, 1, then we can use the info here in the points to find the slope of a line using the slope formula from here. So why don't we do it just for the sake of an example? So let's say this is our x1, this is our x2, this is our y1, and this is our y2. So we're going to start with y2 minus y1. So it's 1 minus 3. And on the bottom we have x2 minus x1, 5 minus 2. So on the top we have -2. On the bottom we have 3. So we end up with -2/3. Okay, we got the slope. Now we can use either of these points and the point slope formula to find the equation of a line. So let's go ahead and do that. I'm going to use point A. So y minus 3 is equal to our slope m, which is -2/3 times x minus x1, which is 2 in this case. So you can leave it like that. That's, not really problematic, but I want to take it a step further, multiply out the right side, and also simplify the left side to move it into the slope-intercept formula. And to do that, we're going to start by FOILing out the right side. So y minus 3 is equal to -2/3x plus, right, because we have negative sign times negative sign, 4/3. And then we're going to add +3 to the right side. Y to both sides actually is -2/3x plus 4/3. And I'm going to rewrite this 3 in terms of a fraction or in form of a fraction. So I'm going to say 9/3 so we can have that intercept as one number. And that is equal to -2/3x. And our intercept will be 4 plus 9/3. 4 plus 9 is 13/3. And just like that, we were able to find an equation of a line. So keep in mind that you need the slope and you need 1 point to find the equation. Sometimes you will be provided with the slope, right? You will be given the slope. The question will say that the slope of a line is blah, 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 and it goes through a point. Find the equation of a line. So when that's the case, super easy. Sometimes you will have 2 points, so you will have to perform one extra step, which is finding the slope, and then using one of the points in the point slope formula, like we just did to find the full equation of a line. Okay, so we got that done in our review. Now let's focus on graphing lines. So in order to graph anything, we need the coordinate system. So let me quickly insert that here. And we have multiple ways to draw a line. We basically need to find 2 points, right? So we need 2 points. And we need to connect them. That's about all you have to do. So a lot of times in these type of questions where you will have to draw a graph of a line, you'll be given with the equation of a line. Let's say 2x plus 2. Or sometimes you will be given a point and a slope. Sometimes you will be given 2 points. That's probably the easiest case because all you have to do is locate them in the coordinate system and then draw it out. But if you do not have any points provided and you are just given the equation of the line, then you can basically do a small table on the side with your x values and your y values, and you can start calculating corresponding values. So let's start with 0 for x. That's the easiest number to work with because then our y is 2. Then let's say I want to do 5 for x. So we need to calculate that. 2 times 5 is 10 plus 2, that's 12. And you can keep going further if you want more points on your line, but 2 is more than enough. So let's locate them in the coordinate system. First, x value is 0. Then our y value is 2. And when our x value is 5, our y value is going to be 12. So since I'm just sketching, I'm not going to label specific values. It might be a little bit off scale. So let me just label these points. This point is 0, 2. And this point is 5, 12. Well, not this point exactly, but this point right here. 5, 12. And now all we have to do is connect the points. And this is our line, y equal to 2x plus 2. Call it a day. So let's quickly review the steps. If you have 2 points, find the slope, find the equation of a line, or just plug them into the coordinate system. If you are given with just the formula of a line, you will have to do your little side table with some basic calculations. It shouldn't take more than a few seconds or a few minutes to find the points. Now, last thing in our review when it comes to pre-calculus is the distinction between parallel and perpendicular lines, right? So parallel lines have the same slope, same slope. They're gonna have different y-intercept. Different y-intercept, but same slope. So think about it this way. It's basically the same line moved right or left in the coordinate system. Now, perpendicular lines have a unique property when it comes to the slope, because if we are given with one line or one of them, then we can easily find the slope of the other, and that m1 is going to be negative reciprocal of the previous slope. That's basically all you need to know to find an equation of a perpendicular line. Obviously, it will be you will have to find the equation provided a point. So you already know how to do that. If you still have any questions, you can definitely review our algebra 1 videos. Plenty of examples regarding that. One thing I want to cover, the last thing, is horizontal and vertical lines. Horizontal and vertical. Vertical lines. Because there's some specific things about the slope that you have to remember, and we're going to use those information about the differences when it comes to slope of horizontal and vertical lines when we work with derivatives later in this course. So horizontal lines have a slope of 0, right? So if we have a quick, let me insert a coordinate system to exemplify that. Just a small one and maybe another one, because I want to give you an example of what's happening at the vertical line as well. Okay, so horizontal lines, let's do maybe, that didn't work. So let's just draw it. Horizontal line. Recollect that the slope is rise over run. In this case, we don't have any rise, we only have run, right? So the difference between our y values is going to be 0. It's just the same y value. Hence, the slope is equal to 0. Just something to remember. Sometimes you might have a tricky question on your homework or on your test saying, calculate the slope of a horizontal line equal y equal to 3, right? You can go right ahead and say, hey, the slope here is 0. Now, vertical lines are quite interesting because they have a slope that's undefined. No rise, no run, or no rise over run. So m is undefined. So another thing to keep in mind, if you have a tricky question on your test that displays a vertical line and asks you to find the slope, you can say, hey, the slope is undefined, and move on to the next question. Don't waste time trying to calculate it using 2 different points, because you're just going to waste a lot of time. Let me see. I think this is it when it comes to graphing lines in the coordinate system. One more thing I forgot to mention about the slope. Let's quickly take a note of that here. If m is positive, your line is increasing, and if m is negative, your line is decreasing. So here's all you need to know in your pre-calculus class when it comes to line. And in the next video, we are going to do some word problems and perhaps use linear equations to do some straight line depreciation. See you there.